Okay, so we are talking about what it means to be neutral and what it means to have a charge. So matter is neutral. Atoms are neutral, meaning they have no charge. And so to be neutral, you need to have equal number of protons and electrons. So anybody on the periodic table is neutral. So for example, fluorine has an atomic number of 9, so you'd have plus 9 for that charge. You must have 9 electrons also. So that would be negative 9 charge. So plus 9 minus 9 gives you an overall charge of 0. If we were to go back to periodic table, which again is sideways. Is this one also going to be sideways? No, this one's not going to be sideways. Guess I'll use this one. All right, so zooming in, let's look at titanium for a second. So titanium has 22 protons. So titanium is 22 protons. And so it would need to have 22 electrons, which is better shown back here. So I apologize, titanium. So see how it says 2-8-10-2. Let's see, so that's 10 plus another 10 is 20 plus 2, 22. So if you look, the number of protons should equal the number of electrons. So that's the electron configuration for any of the atoms. So anyone on the periodic table is a neutral atom. However, if you don't have the same number of protons and electrons, you're going to have a charge. Now remember that protons are kept tightly in the nucleus with neutrons, and then electrons are way out here. It's an E. So it's much more likely that electrons are going to be gained or lost because they're flying around all the way out there. So what happens when you do have a difference, an imbalance of protons and electrons? Well, we call that an ion. Ions are charged. We've either gained electrons or we've lost electrons. In any case, we don't have the same number of protons and electrons, which means we are not neutral. We're not neutral. So what happens if you have more protons than electrons? So there's more positive charge. We're going to call that a cation, not a cation, a cation. And cations are, dare I say, positive. Get it? Cations. It's also got a plus sign right in the middle of the name. So cations are positive, meaning that we've lost electrons. This is the tricky part. Usually you think you become more positive when you gain things. Like when you have more money in your bank account, you would have a positive balance. The difference is, since electrons are neutral, losing negatives is like a double negative. So when we lose electrons, we become more positive. When you lose weight, your size gets smaller. When you lose electrons, you're going to have a smaller, what we call ionic radius. So your size is smaller. Isn't that cute? Cation, an ion with a positive charge. So the opposite of a cation is when we gain electrons. And when you'd gain electrons, you'd be more negative. We call that an anion. So anions are negatively charged because we've gained electrons. When you gain weight, your size is larger. So when you gain electrons, what we call our ionic radius is now larger. Larger now. And so here's just a picture. It's not as cute as the cation of the anion. So in this case, we'd have 3 protons. And we'd have 1, 2, 3, 4, 5 electrons. So we'd have an overall -2 charge. That's why we call it an anion. Remember, these protons are going to stay in there, but electrons can come and go. So we have these 4 different substances. If you see a superscript of a 0, that means it's an atom, neutral. If you see a superscript with a charge, which by the way, if it would be a 1, you generally not see it written. You generally just see this. Na plus instead of +1. F minus instead of -1. So anyways, if you've got a positive or negative charge, you're an ion. Atomic number. Now, that means we need to go back to periodic table for sodium and fluorine. I'll go to the big periodic table. Sodium and fluorine. Sodium is 11, atomic number, and fluorine is 9. So atomic number is 11 no matter what happens to electrons. Same with fluorine. Atomic number 9 no matter what happens. Now, atomic mass. We're going to go to periodic table and we're going to look here and we're going to see 22. Ooh, that's hard to read. 22.9. 22.989. We need to round that to a whole number. So that would be 23. So 23. And again, the mass of an electron is so small. It's essentially 0. So gaining an electron or losing an electron isn't going to change our mass. Let's go back to fluorine. Fluorine. 18.9. So that's going to round to 19. Number of protons is the same as atomic number. Okay, who remembers how to find neutrons? That's going to be mass minus number of protons. So we have it set up already like a subtraction. 23 minus 11. 23 minus 11. 19 minus 9 is 10. Okay, so the only difference now should be in electrons. If they are neutral atoms, my atomic number is 11. I should have 11 electrons. My neutral fluorine atom, 9 protons, 9 electrons. Okay, now, sodium plus 1 means, have I gained electrons or lost electrons? This is the tricky part. Electrons are negative. So when I lose electrons, then I become positive. So I'm positive 1 right now. That means I've lost 1 electron. And so if I've lost 1 electron, I would have 1 fewer than the protons, which would be 10 here. In the case of my fluorine, I'm -1. I've gained 1 electron. So I normally have 9, but now I have 10. So this is the difference between an atom and an ion. Positive ions are called cations. Negative ions are called anions. And then these were protons and neutrons, protons and electrons are the same. Those we call an atom. Okay, I think that's it. And I had all this here. Oh, man. Okay. Thanks for watching.